Hello and good afternoon, everyone. So welcome to this SDC 2022 India conference. So my name is Sushant and with me is Pravin, Ranjan. So we are from Soda Foundation. We are the project maintainers at multiple projects at Soda Foundation. So in today's session, we are going to talk about some of the challenges to container storage from the perspective of data protection. So before getting into the real aspects of data protection and challenges, just wanted to highlight on some of the survey results in and around container storage use cases. So we see there is a continuous increase in the Kubernetes deployments in the last several years, and it is going to only increase in coming days to come. And also not just Kubernetes deployment, also with respect to the container storage and the real use case deployments, we see, and we also, there are several projections about increased usage and increased deployment of these use cases. So you can see some of the figures mentioned in this slide. So what are the key challenges for container data management? So some of the inherent problems with container data management by virtue of being container being used. So containers are ephemeral while data is not. And more or less all the applications are, we can say like more or less they are all stateful. And data persistence is a key requirement for these use cases or these applications. And when we talk about the data, the providers of this data or the storage from where this data is being provisioned are also heterogeneous. And also some aspects related to the deployment, there will be hybrid use cases with respect to cloud, on-premise deployments. So overall, it poses a lot of challenge for the container data management container data management, whatever may be the problem we are trying to solve. So these challenges are going to be with us. So some of the industry product trends in this area. So most of the people who are trying to solve this problem, they are focusing on building end-to-end solutions, building the product ecosystem. And whenever they build such solutions, the solutions are built considering the application awareness in mind. And solutions should be made plug and play. So basically using the service model. So what exactly is container data protection and what are the things that comes to our mind when we talk about container data protection? So to start with this, so we want to illustrate on one of the most popular container orchestration engine, Kubernetes. So how the application, what are the things associated with the applications, and then what are the data protection aspect that comes to our mind. So whenever we think about the application in Kubernetes deployment, so the application will have certain kind of configurations or its resource manifest, what we say, and it might have some kind of a volume requirements to which it want to persist the data. So if you think of any backup restore tool, so those tool or the software or platform, whatever it is, it should be able to ensure the complete data protection aspect for these applications. So when we tell data protection aspect, these solutions should be able to back up the information or the configuration resources used by the application, as well as it should be able to back up the data which is already being used by these applications, so that user will be able to use this backed up data, take it to elsewhere and restore it and continue to use. That is the true sense of backing up an application and restoring the application elsewhere on demand whenever it is required. So for Kubernetes application, to start off with, Kubernetes had a feature, started with the feature volume snapshotting. So what it does is Kubernetes provided certain set of custom resource definitions wherein user will be able to tell, like create a snapshot for me for a given volume. So it through the use of CSI, these calls are delegated to the CSI drivers, wherein drivers used to perform the volume snapshotting operation at their backend. So the backup used to be kept, or in fact, the snapshot used to be kept at the backend. And whenever we want to restore, user can just create a new volume using this snapshot. So the CSI framework will support user to cater to this creating a snapshotting, restoring a snapshotting, thus by providing a kind of protecting your data and restoring the data back. So this is what the volume snapshotting in Kubernetes offers to us. So, but that's not all with respect to data protection. We just talked about the snapshot. So, to cater to the different problems related to data protection in container environment, especially for Kubernetes deployment. So there's a special working group. These are people or the experts who work on different use cases in the data protection and coming up with the missing functionalities and what the design for enabling some of the key data protection supports. So this also involves, because it is not isolated work, so it also has a collaboration with other multiple SIG such as application SIG or storage SIG. So this is a very active working group which comes up with key solutions for burning data protection problems. So below is the link where we can see all the events and happening discussions in this group. So some of the key blocks identified through various researchers or the analysis, these are some of the things, and some of these blocks are already in place, some are in discussion, getting integrated to the Kubernetes and Kubernetes system itself. So what we think of is like we need a backup of volumes, and also we need to have some kind of a repositories where we can keep backups, and there need to be some information to be populated on the volume so that whoever want to take the backup or restore can get some key information related to volume and act upon that. And also some of the uh, uh, functionalities, like when we take backup or the restore for the application, we might have to do some operations prior to taking a backup and post taking the backups, which is known as a hooks. And also some effective mechanism with respect to backup, like change block tracking and group taking the backup in group of volumes and application snapshots and backups. So these are some of the key blocks which relates to the data protection problems for containerized applications. So what are the key backup and restore scenarios? So when we talk about the solution and backup and restore, we expect certain things, or certain things comes to our mind. So one is like the backup, we should be able to take it at the different granular level. My use case may be to take a backup at the cluster level or namespace level or label level, or even at a individual resource level. So also, I should be able to take a backup, maybe only the resource part of application or volume part of application, or both based on my use case. Suppose I want to create a replica of my application elsewhere. Maybe I just need to take a resource backup and deploy it elsewhere, and maybe it is given to someone else to test or to do some activity on this deployment. And backup with the pick and drop of resources and choice of where to keep the backups. I mean, you might have multiple options or multiple providers who can help you to take the backup. So on the fly, I can decide where I should keep my backup based on my use case. And also backups can be instant or scheduled. Maybe I can just tell I want to take a backup of the system or particular scope at this point of time, or maybe on a scheduled basis. Also, the reverse operations, that is restoration. When I want to restore, also I should be able to specify some parameters such as I want to where to restore, how much to restore, whether I want to restore whole of my backup or part of my backup, and where exactly to restore each one of them. So all these things are some of the key use cases with respect to backup and restore scenarios for the container applications. So in the similar line, under Soda Foundation, We have certain work going on. So first of all, to introduce Soda Foundation, it's a sub foundation under Linux Foundation, which aims to foster some of the foster an ecosystem for data management and other projects in with respect to data autonomy. And under this foundation, specifically to take care of or tackle the container data management aspect, we have a sub-organization we can call it is a SODA CDM, Container Data Management. It plans to host a set of projects to deal with container data management aspect. So currently, to start off with, it is only for backup and restore use cases. And going forward, it is planning to cater to the other data management problems such as replication, recovery, and also observability on this. So this is the plan under SODA CDM for data management. So as I mentioned, the first part of this solution is for mainly for backup and restore. So the project is called KAHU. It is a purely open source project under SODA CDM, and its primary focus is to cater to the backup restore for the containerized applications. So the URL for KAHU project is given below. So what is the key goals of KAHU? We have already seen some of the backup restore goals. So this is kind of an elaborated list on those features, kind of granularity at requirement level. So main thing is backup and restore features. So mainly related to different granular level of backup, different options provided during the backup, and also the scope at what level we want to take a backup. And also some mechanism like whether we want a CSI based snapshotting or some non-CSI vendor based snapshotting. And also some aspects like encryption and compression, these things are these parameters to be considered during the backup and restore. So this is the elaborated list of key goals for KAHU. So one of the sub goal is the backup and restore feature. This is at the feature level. And also it plans or it provides storage provider framework. So the motive behind this is we think like there can be a different backup providers or the backup softwares coming up in the future, and our platform should be able to it should provide a flexible way for this provider to get hooked to our framework. So we have a concept called storage provider framework. So we have a well-defined interfaces to which any provider who has a capability to take a backup can hook into, and dynamically he can hook into, and at the same time there can be multiple providers coexisting in the system. So user has a choice based on his use case. He can select which storage provider he want to use for his backup feature. So this is another key part in KAHU's solution for backup and restore. And third part is kind of a management aspect like automation and orchestration, which these aspects will help user to manage his backup and restore through some policies or schedule. We provide some policies or scheduled based backups which user can use and just monitor his backup restore lifecycle. So now I'm going to hand it over to Pravin to show like where KAHU stands and what currently KAHU offers and its plan to deal with the remaining data protection problems with respect to backup and restore. So over to Pravin.
Thank you, Sushant. I will now share the screen.
Okay.
I hope you can see my screen.
Yeah.
Okay, cool. So thank you. So mostly we were discussing about our project Soda CDM, and here is the link in the PPT also. Sushant shared that. So we are developing the backup and restore solution. In this diagram, I will quickly show what we have developed and what is our the roadmap for that. So before that,
can you share? Okay, it's fine now. Yeah, diagram is visible.
Right. So before going to the demo part, first I would like to give some little bit description about the high level flow. So in this diagram, you can see 2-3 component. One is the API server, uh, which will be automatically deployed once the Kubernetes cluster you have. And then the backup controller will be deployed from the KAHU side, and as well as the NFS provider, and there is a NFS server. So in this demo, I'm going to show using the NFS server as my storage backend. And NFS provider, what we say NFS provider is just like a driver for this NFS server. So if you have a storage, let's say some storage from some different companies, then definitely some driver will be there. So you can have that driver that can connect to your storage. And then meta service, we say as a meta service because the responsibility of this block is to collect the metadata of that cluster. And then backup controller, in this diagram only it's showing backup controller, but there will be a restore controller also, which will basically help to restore the data from the NFS server to again to your back to the cluster whenever you need restore part. So these are the high level of diagrams blocks from the KAHU side. So from the user, if you start from the very scratch, so as a user, what you can do, you can create some CR, custom resources, that to create a backup. And in that backup, you can pass some parameters. Those parameters already it's there in our APIs. Maybe you can take a look. Here, you can, if you go to the API of Soda KAHU, then there are so many parameters, include resource, exclude resource, namespace at the granular level also there. So similarly here, just I was saying that this based on your requirement, based on your resource list and all, you can fill the CR, that which namespace we want to be included, which namespace you want to be excluded. All those things you can create as CR, and then you can send a request, create backup for that. And then internally backup controller will take your request, and internally it will call to the NFS provider or NFS server. Then your backup will be created. Similarly, you can have your restore CR, that which resource I want to restore, on which namespace I want to restore, and all those things you can create. So create restore, and then internal backup controller, restore controller will from your CR, it will pick from which server it has to restore, and finally it will download the data to your cluster and apply that to your cluster. This is all things we are talking from the meta service perspective. Similarly, we have the volume service also. For example, if in your deployment or if in your pod volumes are deployed, we can do the volume backup also. Volume backup means all the data can be stored to your some of the storage, and then again it can be restored back. So this in the previous diagrams I was showing the overall blocks. Now I will quickly show the demo, how we are going to create the backup and how we are going to restore the backup. So for now, I will simply show that which all components are deployed in my cluster. So you can simply get deployments, and in test namespace, I have deployed my components. So one is the KAHU backup controller. This contains the backup and restore controllers. And here the NFS provider, your driver, and this storage backend. So these are the optional in the sense it will be vary from the user to user, but the KAHU and backup controller will be there with you. Now, always need to be deployed. Once the things are running up and running, these deployments, then you can create a backup. So maybe you can create, I will show the how you can prepare the backup.yml. So for simplicity, I have just taken only one resource. Just I want deployment as a resource, and I want out of 3 deployment, just I would like to backup just only one backup. And here what I have given is regex is true, meaning is that all the name starting or ending with backup, basically starting with backup and then after dash, it will pick. So here meaning is a star, So all the deployment of backup, name with backup should take it. And that is from the test namespace. Exclude resources we have kept empty, so only these resources will be included. Now simply I will go and I will create that. Before that, I will like to show that we can get the backup location also. So if you see the backup location, I have the backup location. Backup, sorry, typo.
Backup.
My bad. Yeah. So if you see that I have a backup location of AS, and if I will describe this NFS, then in that you will see that all the details of the provider will be mentioned in the spec. So for example, I have a provider name that is a storage driver, similar to storage driver, NFS provider, and what are the config required to connect these things will be there in the config. This can be the key and password. It can be the some secret key name and whatever. It's a configurable altogether. So now I have already prepared the backup.yml, which basically does the deployment in this namespace. Simply I will go and I will create the backup. So if you see that get backups, for now I don't have any backup, no resource found, but now I will go and create a backup. So create a -f and then backup. So this backup demo is now created. If you see now, so this is created, and if you would like to describe again, we can do. And then the status is complete, stage is finished, complete. And for our internal purpose, we can see in the storage also whether the backup is there in the NFS storage or not. So just now you can see that this is the date 5/20/5/49. This backup demo is now created. I mean, created means it collected all the content from that namespace and it stored in the NFS server. Now, if you'd like to see what it has collected, so you can see here, it collected the deployment backup, then the service account in that backup means all the dependent resource or entity of that deployment will also be collected. Service account, cluster role, cluster binding, and all those things it will collect. Even if this deployment has the persistent volume claim, it will collect. But in this example, it's not there, so it's not collected. So basically, it will collect all the dependent resources also. Now, I would like to say that I would like to show now the overall namespaces there in my system. So get namespace -a. So currently you can see that there are a few namespaces available, test NS. Now what I will do, I will try to restore this backup in different namespace. So if you see the restore YML, so what I'm doing that, I'm just giving the name a restore demo, and from which backup I have to restore. So backup name should be given, backup demo. And the namespace mapping means this backup demo is from the test namespace, and I want to store here in test namespace demo. So it will create a new namespace and store all these things into that namespace. And simply I want the deployment part same. Whatever the backup was there for that deployment, it will pick and store into this demo. So here again, also you can have some different parameters. For example, exclude resources, include namespace, exclude namespace, all those things, even the hooks, pre-hooks, post-hooks, you can run and you can have all those things in the backup and restore YML. Now I will go and create the backup restore now. Okay, get restores. So currently there is no restore. Now I will go and create a restore this. So this restore is now created. I will check the status of that. Demo restore. And now it's finished and completed. So now the backup is done, restore is also done. So that I can see from here. You can see just now 30 seconds ago, the new namespace was created because I wanted that it should store into the new namespace. And what we can see that we can check which all resources are available in that namespace. So as you can see that KAHU backup is deployed, and it is basically deploying and all those things. And after some time it will be ready. So in that demo, what I have shown is that maybe you can create a backup and you can restore the backup. So I have created the backup here using these specs. And similarly, I can create a restore in the different namespace using the means the backup has done in the NFS server. Again, the restore also I can collect it from the NFS server and restored into my cluster. So that's it from my side, a short demo about that. And if you want to visit more, maybe you can visit our GitHub ID.
We'll just show the details.
Right.
Okay.
Right. So
okay.
Thank you,
Thanks,
Sushantha.
Pravin.
Maybe you can.
Yeah, that's all from our side. So some of the links for reference. So this is the link about the Soda Foundation, where sodafoundation.io, where you get all the information about the foundation, different projects posted, and you can join Slack, Twitter for better communications. And Soda CDM is the link which Pravin was showing currently. And it's a purely open source project, and we would like to have more and more communication and contribution from you people, and together we learn. And this is one of the key area and very interesting area. So hope we want to see some of you guys will join the foundation and contribute, and we learn together and develop this together. Thanks a lot. Thanks for listening to us. Take care. Have a good day.